times and actually help us. So. No, we're happy that you're back. Class is not, especially a class this small, it's not the same when one person's missing.
Yeah, except for Brian.
Gosh, that's rude.
Well, it's not the truth. Truth hurts, am I right?
Sorry, I forgot I need to pull up a smart thing so I can just take pictures of these. All right, so can anyone remember the property of how this line right here coming off the center will interact with this chord right here? Caleb?
Sorry, I was a stretching bug.
Michelle?
It bisects it.
How do we know?
Because any point or any line coming off the center that is perpendicular to the chord bisects the chord.
Ah.
It also bisects the diameter because it comes off the center point.
What'd you ask again?
Well, now I know what
I
to
was
do.
stretching,
Okay.
so.
Yeah, so when we see the right angle, this only works because it's perpendicular. When we see the right angle of this little segment here, that's going to bisect your chord. So this becomes a 7 and this becomes a 9 because I also know that center point bisects the diameter. And then I can use Pythagorean theorem.
Alright, coolio. Wait. Can you say it again?
So because this is a right angle, I know that it is really like trying to go all the way to the edge as a radius, but it got stopped by the chord. And because it's perpendicular to the chord, I know that has to bisect the chord. Because the only other option is if it's not perpendicular, say something like this, then I know that this portion would be longer than this portion because how we know the angles work and if we set up different triangles. So it has to bisect. So since I know the whole chord's 14, the part that is in the triangle is 7. I know the diameter and then the radius I find to be 9. Cool? And then 9 squared minus 7 squared will give you your 5.7. Other questions from 8-4? Michelle. Okay, what? 11. Sorry, this is not working. Okay, try again, but capture my ink this time. There it is. 11. Oh, so this one is just kind of hard to visualize because it's trying to represent 3D on a two-dimensional surface. So this says in the figure, the sphere O has a radius of 15. And since it's a sphere, that radius could be pointed like any direction. It could be coming off the page at you, be going back into the page. So then it's intersected by a plane 3 millimeters from the center. So if that plane... So I had to talk through this with somebody. So imagine like a ball that had a disc in the middle of it that's not quite as big as the ball. So that disc can't span the center. It drops down just a tiny bit. No matter what we do, it's not in the very middle. So imagine that this like disc is almost the size of the circle, but it's 3 millimeters dropped down from the center. So we want to, the nearest tenth, find the radius of the cross section of y, which would be like the radius of that little disc, or the long leg of this triangle that's set up. So we just end up looking at the triangle. And we're solving, that's a bad question mark. But we're just solving for that. Other questions on 11, or sorry, 8-4? Yeah. 12. Circle J, diameter HK, KL is equal to LM, so we have an isosceles triangle. LM is also congruent. So we have an equilateral triangle. Prove that KI, L, and KIM. Anyone want to walk us through this? Ignore all the red stuff. That's too complicated to read. I mean, this has been posted on Schoology. If you want to read through it, you can, but it's easier if we talk it out. Michelle?
Okay. Well,
Yeah, you can come up if you want to draw and reference stuff. It's hard if you don't.
Well, this is an equilateral triangle because the distances of each of these are equal, so this would be equal to this. And,
Mhm.
yeah. And then the diameter, this is like a chord, so the diameter is, well, it bisects because, it goes through here and I'm trouble explaining. It bisects this, and that makes each of these equal, and then it's like side, side, side because they share a side, and then these two sides are equal. I did not do a very good job of drawing that, but yeah,
Now, how do you know it bisects?
that's a great question.
You're
And I'll let somebody else answer that.
Darn.
Wait, I might have it. Can I go?
Sure.
Alright. You got it, Brian. Alright, so we have the center point right here, right? Center point. It's below that. Okay.
I know
Center.
my orientation's off.
Alright. So that's the center point. That's the center of the circle. That's why I call it the center point.
You can tell the class.
No, I'm
Don't
talking
teach
to
me.
you.
Okay.
Alright. So then this line would have to go directly through it, which is half of the circle. Circle.
Boy.
Shut up. And then you have this line right here.
Chord.
Chord. Yeah. That is split in half by this because it's the center and those have to be congruent because stuff.
I agree with what you're saying based off what the answer is. I still don't know how. How do we know that it has to?
Because that's the center, and if that's perpendicular to that one, then it's stuff.
What tells you that it's perpendicular?
I don't know. That's a straight line that goes. I don't know. All right, next question. Go ahead.
Nice try, Brian.
I don't see why it couldn't just be skewed and it's not.
I know, that's what I'm pushing us to explain.
But like with the information given, I see no way to say that it's not. That it can't be skewed. Oh, I think I know.
I really want one of you to make this jump. I don't want to give it away. Michelle? Sorry, you beat her out by a few seconds.
Well, this isn't really like why it bisects, but it's a connection that might help. KJ is a radius of the triangle,
Mm-hmm.
and yeah, that's all I got.
So, we've talked about an isosceles triangle, right? And with everything we've talked about in this chapter, we now know something about how the angles relate to other things. Okay, still nothing? So, Megan?
Okay, so you're told that KM, LM, and MK are all the same,
Mm-hmm.
which means that ML, KL, and MK are, like, the lines are all the same.
Mm-hmm.
So, wait, yeah. So if two sides are the same, isn't the third the same? Because you know KI is going to be the same. What?
You know KI is going to be the same.
It's the same on two triangles because it's the same line.
So, just so we're all looking at the same thing, this is I.
Yeah.
Yeah, just checking.
Okay.
So you're saying KI is the same as KI because reflexive.
Yeah, so
What we're grappling with is how can I prove that this is congruent to this?
I don't know. The proof statement right there just says it.
Well, then it says reasons. We need, what are those reasons? Like, but so.
Okay, so since all the arcs are congruent, that means all the angles are congruent. And so then you can see. Oh, I remember. Okay, so since all the angles are congruent, you know that since it's the diameter that it bisects K,
Close.
right? I know. Oh yeah, that. And so you know that. Wait, can I?
Sure. You got to realize we're using the converse here. We're not using the fact that they're perpendicular to prove the triangles. We prove the triangles and use that to know that they're perpendicular. but it's how we prove the triangles that's the part that we want to make sure we do correctly.
So then if you know that it's like the triangle angle sum theorem and that they're all the same, then all of them has to be 60. And then if this is 30 and this is 60, then this has to be 90. We know it's a bisector, right? Because
It's not given as a bisector.
yeah, I don't know.
But is it a radius or it has to go straight through?
Now I could prove that it's a bisector. It just isn't given to us. Emma?
I can't
I got
do it.
So 2 fingers to erase. 1 to move.
Yeah, okay. I'm not gonna get it. So these are the same because they're both radius, and this is the same because it's the same line. So then it's the same triangle because it's reflexive, I think. It's just the same situation.
You're really close. Can I take them? Or or are you gonna keep going?
No, that's all I
I
got.
just can't write from the other angle. I have to be right here. We know. Yeah? No?
Wait, yes.
Yes? Okay.
Okay. No.
Yeah?
So, never mind. You don't know. Never mind. Remember that we don't know that's a bisector yet.
Michelle?
So radii, they have to, in an equilateral, they have to bisect the angle at the end because they make congruent isosceles things, and that means that this has to be congruent to this, and this has to be congruent to this.
There we go.
And then, since that is congruent, wait, okay, yeah.
You're using too many pronouns is the only thing. That, this, like,
Yeah.
this stuff,
Yes,
that
this
you
stuff,
you're on the right track. We just need to work on your explanation.
Yeah.
So what a couple of people have told us, I'm just going to clean this up a tiny bit. We can draw a line here to be a radius, here to be a radius, and we already have this radius, which will then give me this triangle is congruent to this triangle. You with me? There, and I don't know if I'm following their exact process. It doesn't matter. I mean, there's always multiple ways. Once we know they're congruent, we know their angles must be congruent, CP, So then I know that this angle up here at K and this blue angle up here at K are congruent, which tells me that this diameter is a bisector. Once I know that diameter is a bisector, I can then say that it's going to be perpendicular down here, and then I can prove those triangles congruent. Now, there's other ways we can do that also. We could look at like the small triangles formed down here, but when I can use 2 radii and then 1/3 side that I already know to be congruent, it's pretty easy to solve side-side-side congruence. But it's drawing those extra radii to be able to see that really helps us make the jump. Caleb?
This is one more question about like later and down into like once you get to the higher math.
Yeah.
Will they actually expect you to write out the entire proofs?
A lot of times we do 2 columns. So it would just be like, I know that JM is congruent to JL, and then your column with your other column is your reasons, and you would just say both radii or something like that. And that depends on your teacher, like how specific they want your reasoning. But when we look at the reasons they give, like reflective property, a given, a converse of a theorem, all radii. So this is your all radii are congruent. So both radii, you could all radii are congruent, whatever.
We have like all the theorems we've learned.
You don't need to know numbers. You just need to state what they're saying. So I didn't prove these congruent because the bisector. I didn't prove them perpendicular because, what am I trying to say? I'm getting tripped up on my words. We're using the converse because I'm not using the perpendicular bisector theorem. I'm getting to it backwards. So that's why we would just say the converse of perpendicular bisectors. I still state that they're perpendicular, but I got there through the converse. And I think Math 3 does a lot more with proofwriting.
We have to memorize all the geometry.
Not numbers, you just have to be able to say what it is.
Do you have to memorize like
probably yes, but most of them you can communicate, and it's just thinking through what am I saying and writing that down. Like, what am I thinking? Other questions on 8-4? Chords are. Oh, the other way, by the way, that we could have done this, that's kind of a fun way, is if I know this angle, then I know the arc that it is intercepting. I know that this angle is congruent, so I know this arc. I know this angle is congruent, so I know this arc. And then I can set up other smaller arcs by drawing out either radii or whatever I want to. So I could draw out a radii here, and use this part of the angle. And then I could draw the radii here and use that part and use these separate pieces of the arcs. But I could also come up to K and draw the arc relationships down from here. This was the other way that they could have taken you. So this, once I've proven those red and blue I didn't take a picture of it. Once I've proven those red and blue triangles, I knew that those angles were congruent. So this top angle related to this arc will give me the same size arc over here because this top angle is congruent to it. So I could relate the arcs congruent and prove it's a bisector that way. There's always a few different ways that we can get around to it. That's if you want to do the arcs, if you like working with the arcs. If you like working with the angles better, work with the angles. There's probably a third way that's just as easy, but I'm just not thinking of it right now. Yeah. So, like, if I do the triangles first, and then I use those top angles to talk about the arcs, and then I can use those arcs to justify the bisector. So I'd, like, alternate. Other questions, 8-4. In circle X, AC is a diameter, ED is congruent to EB, where's ED? Okay. And what can you conclude about arc DC, arc BC? I bet this is actually going to tie back to what we were just talking about. So, if I know that that's a diameter, and this is a chord, I don't know that they're perpendicular yet, so be careful with that. But I could look at just this edge and AC's diameter. And actually, I'm giving away a lot. Anyone want to get me started on this? What can we state about DC and CB, those arcs? Yeah. Try to be descriptive with your explanation. Don't use things this and that.
So you draw a radius off of this, and then you draw another radius off of this. There we go, coming to that end. That is a terrible line, but okay. And then you know that these are you have to prove that these are equal.
How? I have two shared sides, but I don't know anything about that top angle yet. Those angles that you just marked?
Correct.
I agree with how you started completely. I just want you to defend it.
Yeah, I'm trying to think about how to do that.
You're really, really close. Like,
So I don't know. I'm gonna have somebody else come up.
don't lock yourself into right triangles. So think about this as and I bet you'll figure it out. Don't lock yourself into right triangles. So, exactly what Michelle said. If I can draw a radii, a lot of times that can help me. Can anybody see it? We want to relate two congruent triangles so that we can use CPCTC to relate angle sizes. Going once. Going twice. Can we prove those triangles to be congruent? If this is a radii, and this is a radii, and this is a shared side, and I already know my third sides to be congruent, I've got congruent triangles based off side, side, side. What? So the question we're being asked is, what can we say about this arc compared to this arc? But we're just trying to set up some like what do we know sort of stuff.
Oh wait, okay.
Yeah.
So, if you look at theorem of 84,
Which ones that relate to? Because I don't memorize the
it's
numbers.
the one where, you know, it's the one.
I don't know how to explain them either. They're really hard to explain.
See this one. So this is just that, but with some lines drawn.
Ah, okay, you're right.
So if you just pretend those lines aren't there.
So the only thing that we're trying to prove, like the only thing we're missing here is that here they tell you that CE is congruent to ED.
Ew.
Yeah, that's what we're missing. So you're right. This is where we're trying to. So theorem 84 deals with the diameter and the chord, and the chord being bisected by the diameter. So if this is a right angle, the diameter bisects the chord. If the diameter bisects the chord, then it's a right angle. So I can prove it either way around. When I set up this red triangle related to this blue triangle, that by CPCTC relates that this, I'm going to erase all this now, this angle is congruent to this angle. Are we with me there? Because those little, the one triangle that was here, the other triangle that was there. So then, based off that, Ethan,
You can based off of like if there's the
so both angles relate to the same. I might be taking a further way than you need to. Like I might be going out about, like, if you imagine here's where we're going, I might be doing this, but here's how my brain works. Do you want to, or do you?
I was gonna go the straightforward way.
So what would be your straightforward way?
Well, if they're congruent, doesn't that mean that it bisects the angle?
Then the arcs that they intercept, so if these are congruent, and then I look at the bigger triangles, so I think what you're relating now is these triangles.
Well, no, I was just gonna say if never mind. I was thinking of things related that didn't.
Okay. But if we now set up that red triangle compared to this blue triangle, we could say that those are congruent based off side, angle, side. Or, here's a different way, because we're talking about chords and arcs. If I come up and do this, sorry guys, I like showing you different ways, so I don't know what's going to connect with each individual brain. This angle is the supplement to my blue. This angle is the supplement to my red. I can set up another set of congruent triangles. And this is really like not necessary, but if you really like relating the chords. And then I know that these angles up here, which intercept these chords, that's one way that I can get to the chords being congruent. Now the other way is just once I get my red and my blue related to each other, then I can say that these angles have to be congruent to each other, and if they have to be congruent to each other and they're a linear pair, they have to be 90 degrees. So I could have stopped once I did my red and my blue triangles here and just use the triangle reasoning and the linear pair. They have to be 90. It has to be a bisector. Yeah, Carmen.
Wait, but once you figured out that like the like red angle E, I guess, and
Yeah.
blue angle E, once you figured out that those are congruent, couldn't you just say then arc BC has to be congruent to arc BC?
Yeah.
Okay.
And the reasoning behind why that has to be true is those congruent
Oh, that's
triangles.
I was confused. Like, why can't you just say it in the first place?
Yeah,
That's right.
the reasoning behind, like the proof of why it works is the triangles it makes. But yes, that's a property that we accept because of the proof of why it works.
Okay.
The main reason that we use the theorems is so we don't have to explain why it works. We just say theorem whatever, because in that theorem we prove these triangles or that sort of stuff. Other questions? I don't even know. When's this class over? 38. You have a question on what? Any other 8-4? chords and arcs, all fun stuff. All right, 8-5. Gotta jump 10 pages.
Number 17, 8.5.
Let's check. I know we had some 16, 20. So 5. There we go. 5, 15, 7. Okay.
I couldn't figure out how to get C. That's the one. So the 150 degrees. I couldn't figure out how to get that one.
How to get C. Michelle? Are you coming up? Sweet. Makes my job easier.
So you can draw lines here, and then since this is like kind of like, you know, part of this angle is going to make B, and the other part of this is like intercepts with
So let's label.
arc C.
I see what you're saying, but let's label so that everyone can see. So what Michelle's saying is when she drew this red line, this green angle relates to this arc, right? Am I interpreting what you're saying correctly? So then this angle relates to this arc. So I can solve B by breaking up my green and my blue right here. How do we know these inscribed angles relate to the arcs?
Since well, the inscribed angles are half of the arc, and so this has to be, what was it, 18? Yeah.
18.
So this green angle
Ooh,
has to be 18, and since it has to add up to 78, that means the other angle has to be 60.
So then B
It has to be twice as 60. So
must be 120. Everyone with us, how we got here. So we still got to figure out C. Now, like we just did, I can use, and this is where it gets a bit hairy. Trying to decide what colors. I could use this red line that goes across and this edge of my quadrilateral to intercept this arc and realize that this small portion of this angle has to be 60. You with me on that? Because it intercepts the blue arc. From there, that would give me that this small green portion would have to be 27. And if that has to be 27, then this arc over here must be 54. I'm missing a lot of. And then we can solve C. Back to Dr. Smith. Draw a line. If you're stuck, just draw a line. Then try to draw another. Then try to make some relationships. Ethan? Okay. I mean, there's always multiple ways. So, how'd you do it?
I looked at angle A.
Okay.
Angle A. And then here, can I come draw?
We have another theorem that I think people are forgetting about, too.
Yeah, okay.
When we have a quadrilateral inscribed in a circle. Go back and check your notes if you're sitting here confused at all.
Two opposite angles in a quadrilateral inside a circle are supplementary.
That's the theorem that we're forgetting
Angle
about.
A would be 93 because that's supplementary to 87. And then this arc all the way to here would be 93 times 2. And then you would subtract 36 to get this arc.
Does that make sense? So we know that opposite angles in a quadrilateral that's inscribed in your circle must be supplementary because the two arcs that they intercept sum to be 360. So you can use that property as well. Multiple ways to get to Florida. Michelle?
17. Can you do 16 before that?
Didn't somebody ask about 15 also?
And 9. Yeah, I have 15, 16, 17, and 9.
9? Okay. Let's look at 9. Hum da dum dum. So if I just start labeling things that I see, this angle intercepts an arc that's 50, so the angle must be,
I have a quick question.
yeah,
What angle is B related to? Like, I couldn't.
I think it's probably this one.
Oh.
Wait.
Does that solve out to be 90?
Yeah.
That's what I figured. But if we're trying to solve B, there's a different property that takes me to get B.
Oh, I know this.
Ethan.
Okay, so, in a triangle inside of a.
Inscribed in a circle.
Inscribed in a circle, if one of the sides is the diameter, then the side opposite to the diameter.
Angle opposite to the diameter. But yeah, we're with you.
Opposite to the diameter would be 90 degrees.
The angle opposite or below hypotenuse, the diameter, has to be 90. So that's how we can solve B. But so I just like listing like the things that I know and figuring it out from there. So we know B based off a theorem. We know our 25. Carmen?
We can also figure out A by
Okay.
you can see that related to the 39 degrees, so it's like double 39.
So double 39 tells me that A is 78. Then to find C. Megan?
Okay, so
Sure, I don't care.
So this whole half thing is 180 because this is the diameter, correct? So since this part is 50, this one's 130, and you can see kind of that this leads out here. So this would be one half of the 130 or 65.
So she's saying C, the lines used to make it intercept this arc, which is all that's left over from the semicircle involving 50. So this has to be 130, which means this has to be half that, or 65. Any questions? Anything else from the front? So we're good through 13? On the back, was it 15? Was the first one?
Someone else wanted it, but I wanted
16?
I want 15.
You want 15? Okay. Now the problem is we don't know if that ray is a tangent line. Find each variable for each circle. The dot represents the center. Yeah, we don't know that this is tangent. Man, that'd be so easy if it was. Michelle?
Well, first off, finding A, it's related to the arc, or the arc is 38.
How do I know?
Because there was a theorem thingy that said that the center, or an angle coming off of the center
Mhm.
was the same as the arc. And then, so A would be half of 38. So that would be
19.
19. I can see, I swear. But, and then, well, since you have 38 and then you have 146, C is the leftover in the 363.
Yeah, so we really only have 3 arcs around my circle. I have the 38, the 146, and the leftover. So how much is left over?
176.
176. And to find B, it's going to be half of it.
Why? But isn't like the B1 angle kind of off the circle?
Hold on, let's make sure that we justify it all the way then.
But it doesn't say it's a tangent line, so
think maybe we just have to assume. Maybe they forgot to say assume that lines that look tangent are. Because I think in 16 we also assume that that's tangent.
And 14.
Yeah, I think we just assume it is. Because, I mean, it wouldn't make any sense. It wouldn't tell us anything otherwise. But pay attention. It's not tangent to a radii, so it's not 90. So when we go and look at our arc measure theorems, our arc measure theorems tell me that if I have a tangent and a chord, that angle will be half the intercepted arc. So I think we just assume that it's tangent. They seem to not write their practices as well as they should. They need to hire better people. 16 also? What? Do you need 14?
No, he said Dave said they should hire him. Right? He needs to be 14 before you get any job.
So, we've got angle A probably relates to arc D. Angle B and angle E are related in a triangle together. Angle C involves what we can assume to be a tangent. We've got a diameter shown. So how do I start solving these things? Michelle? Okay, one very small thing that might help.
Triangle EB and then the unlabeled part there.
Okay.
That's a 90 degrees because it's a chord that has the diameter going through it.
But you don't know that they meet at a 90. This chord could be skewed like this.
Oh, never mind.
Right? So that's like now if I knew that these were perpendicular, then I know it's 90. If I know that this is 90, I know that they are congruent. Caleb?
I was asked this question. We're assuming that line going through the dot's the diameter, correct?
Yeah, it says that in the center,
Alright,
the dot
so
represents the
then,
center.
first of all, you can assume D is 180. Sorry, not 180, my bad. D is 70 because that has to equal 180. So, but then you could also find that the sum of angle B and angle A has to be 90 because its thingies go out to connect to the diameter.
Oh, I get it. You can stop now. I get it.
Do we need to keep, does anybody want me to keep going? Please be honest. A then relates to our 70. B relates to our 110. E relates to our 76. And A I can solve as being the complement of B. Or like, yeah, there's multiple ways that we can do it. Fit in a couple more. 17. Zoom this out a hot second. Quadrilateral ABCD is inscribed in Z. YX is tangent. I'm glad they told us this now. Measure of XAD plus YAB. Oh, this isn't that bad. Ignore their explanation. We are trying to prove that this angle plus this angle equal this angle. So if I were just to like talk and reason through it, we know that angle C is gonna be supplementary with angle A, right? Because they intercept opposite arcs. You with me there? So if A and C are supplementary, and then A, and let's just call this like X and Y, these angles right out here, they also have to be supplementary because they're a linear trio. So really just reasoning through the quadrilateral rule, and then my linear pairs or trios or whatever you want to call it rule can really get me there. I mean, we can go the long way and talk about the reasons of the arcs and everything else, but that's really just how we get there. Who asked for this? So I'm curious where the confusion came from.
I don't know. I was just kind of like.
So you have to remember, the first thing you have to remember, which is weird to get used to, is that these angles have to be supplementary. And then these angles have to be supplements to the A. Like together, they're supplementary to A. And that just kind of takes me there. We could justify with arcs. If we wanted to use the arcs, we could write it all out long ways. 21. We're gonna do more of this Monday. I'm not gonna ever rush through when you guys are asking questions, because the biggest thing that we want to encourage is asking questions about math. Let's pick this up on Monday. Continue, please, to comment on Schoology so I can make sure I know how to solve the problems before we get there. I mean, really, that's me being honest. So continue to let me know on Schoology. Post on that comment that I have on the updates page, and we'll pick this up Monday. Hopefully wrap this on Monday and then continue on chapter 10. Thank you, guys. Have a great day. Thank you. It's weird that we're going to lunch now.